Okay, hello everyone. So I'm back with another data analysis video. This follows on from the previous one where I talked about box plots. So we're still looking at data visualization, how to explore your data using visualizations. And as I said in the last video, I demonstrated how to create box plots using matplotlib and seaborn. In this one, I'm going to talk about violin plots. So I'm going to demonstrate, as I normally would, how to use matplotlib and seaborn to create a violin plot. Violin plots are kind of like a box plot in that they're used to plot categorical data or look at the distribution of scores on between groups on categorical data. But they actually convey, they can be used to convey much more information than a box plot. So they, like a box plot, they provide a representation of the median, the interquartile range, and the kind of whiskers, that being 1.5 times the interquartile range in most cases. However, they also make use of like kernel density estimator. That's overlaid instead of an actual square box. A KDE is overlaid, which shows the actual distribution of the data using like a probability density function. So that generally makes them more useful and informative. So anyway, you'll see what that means in a second. So I'm gonna start by importing the usual software libraries using their conventional nicknames: pandas as PD, NumPy as NP, matplotlib as PLT, seaborn as SNS. And I'm going to continue. I used this in this data set in the previous video. I'm going to do the same thing again and kind of demonstrate in a similar way how to get violin plots, as we used it to obtain box plots. So I'm going to use the Titanic data set again, and I'm going to read that in from a CSV file saved on my computer using the pandas pd.read_CSV method. If we look at the head of that, you can see it's got the usual sort of variables in this nice pandas data frame. So we've got whether someone survived or not, and that's a dummy code 0 or 1, their passenger class, first, second, third, age, sex, various information that we could use to visualize. One thing I am going to do, I did this previously when we were looking at box plots. I'm going to create a categorical variable called alive, and I'm going to use the .map method to map categorical label values to these two dummy codes for survive. So I'm going to take the survived variable from Titan, this Titanic dataset. I'm going to use the map method, and where there's a 0, I'm going to change that to dead, and where there's a 1, I'm going to give that a label alive. But I'm not going to change this particular column. I'm going to create a new column and append it to the end of the data frame. I've said a couple of times that I prefer to do that, and then your original variables in place, and you can also visually check if something's worked. Okay, so having done that, we should now have, if I ran the header again, we should now have an appended variable called alive, which has these categorical labels, dead or alive, essentially. So let's create a violin plot using matplotlib. And the first thing I've done is I've used matplotlib plt.figure and specified the figure size, so it's a reasonable size. And what I have then done is created, I've created a couple of new objects, dead and fair and alive and fair. So what I want to do is look at the differences between the fair paid between the people who died and the people who survived, essentially. And to do that, I've created these two new objects, and I've used the .log method to extract for one group all the people who died from the alive categorical variable we just created, and group them by their fair, essentially. And the same for alive, all the people who survived and their fair, essentially. So I've done that a couple of times before. I did it when I was demonstrating box plots, and I'm going to then pass these object names in to the violin plot as a list into this violin plot method. What I've done is I've specified, you don't need to, essentially. I've set this equal to some sort of object. I've called it, I should probably call it tiles, something like that for violins, a violin plot, and I'm using plt.violinplot. So to get a violin plot, the method in matplotlib is .violinplot, and I've passed it a list containing dead fair and alive fair, those two new objects. And notice that you've got parentheses, but the list is passed in square brackets as well. Put a title and a label, and I've used plt.show to sort of make it look all nice and tidy. So there we have a violin plot for fair based on whether people were dead or they were alive, and this is the dead group and this is the alive group. Hasn't given us, it's created like its own scale on the x-axis. It's labeled fair here, and you can see there's kind of quite a range of scores. It looks like people who are alive, those, people who paid higher fares, more likely to be in this alive group, but there's a lot of clustering at the bottom. It's not a particularly informative violin plot, but you can see here, this is the kernel density estimator. And it's symmetric. It's the same thing on each side of this kind of line, essentially. So that's just the kind of basic violin plot, and it required a little bit, as it usually does when you're plotting with matplotlib, it required a little bit of code. Let's try a different one. So what I'm going to do is I'm going to do a similar thing as above. In the data set, we've got this passenger class 1, 2, and 3, and it has, if we did the info, you'd see that it's been imported as an integer rather than a categorical object. So what I'm going to do is create another variable, so a categorical variable with class labels, and I'm going to take that p class variable and I'm going to use the map function again, and I'm going to map where there's a 1, it's going to be first, 2, second, 3, third. Okay, so first, second, and third class. Okay, and I'm just appending that to the end of the data frame. If I run that now, you'll be able to see there's the alive class that we created, and now we've got this categorical class, third, first, and these map on to the passenger class numbers. Okay, so what I want to look at is if there's a difference in age between passenger class, essentially. And that will allow us to plot to obtain 3 different groups of violin plots for comparison between them. The difficult thing is if I run this isNA.sum, so what I'm asking for is a count of missing values for each of the variables. If I run that, you can see age has lots of 177 missing values from the data frame, which is a lot. And if you try to create this plot by looking at differences in age between first, second, and third class, you would find that it would produce some axes but wouldn't actually plot any data. And one of the issues is you've got all this kind of missing, you've got all these 177 missing values. There's quite a big data frame, but there's a lot of missing values there. So what I'm going to do is, to allow us to do this, I'm going to create a new object called Titan2, so a separate data frame object, and I'm just going to extract as a list the 2 variables of interest, which are age and this categorical class object from it, and I'm going to drop any missing values. So if I run this and then we look at the missing values from this new data frame object, we should see that we have no missing values. We've got a smaller data frame, the data set, we've reduced it by 177 participants, but it should allow us to plot. So again, what I'm going to do is create the plot using matplotlib, and I'm going to create some new data frame objects as well, or some new objects to pass as arguments into violin plots, similar to what we did when looking at box plots. Firstly, I'm just going to specify the figure size so it's a reasonable size that we can see it, and then I'm going to create these three objects: p class 1, p class 2, p class 3, relating to the first, second, and third passenger class. I'm going to use the .loc method. I'm going to use the Titan2 dataset, and basically I'm going to extract for P class 1 all the first class passengers and the data for their age, and save that in that object. P class 2, same sort of thing. I'm going to say I'm asking for category class is exactly equal to second, and extracting their age from that as well. Same for the third. And then all I've done is specify plt violin plot. I've not set it equal to an object in this case, don't need to, but I've passed a list containing these three objects, so they're the three groups that it's going to plot. And I've also added this extra argument here, show medians equals true, so it should give us show where the median is. If I run that, what you see is we get these three groups, and it's represented the median line. You can see the kernel density estimation for the variables, so quite spread out there for 1 first class and 2 and 3. So age, generally it looks like generally people in first class were a bit older. People in third class had their kind of were on average generally much younger. Okay, so that's matplotlib, and as you kind of know, or as you can see, it requires to create your plots, it requires a little bit of coding and grouping variables and things like that in some cases. So that's where seaborn, which is obviously built on matplotlib, comes in quite handy. So yeah, we can often do the same sorts of things, but with much simpler code, all put together in one line using seaborn. So let's demonstrate that with a couple of things. So what I'm going to do is use the sns.violinplot method from seaborn, and I'm using the Titan data frame object, and I'm specifying .fair. So let's firstly create a violin plot for fair, and there you can see there's lots of clustering of fairs kind of at this low end here. Much of the density of it is, and then there's very much fewer. There's some quite extreme values there. People paid a high price for their ticket. Probably wish they didn't. Likewise, let's run this one. What I'm doing here, so all I've done there really is kind of plot one group. So plot the distribution of scores in terms of fair using one violin plot. But the main thing of interest is obviously we want to compare groups. So what you can see here, on the x-axis I have plotted the passenger class, the categories, third, first, second. It's ordered them automatically based on what it thinks is, again, I'm assuming on for some particular reason, it's put third, first and second in that order. And we're looking at age, so we're basically looking at the same kind of plot as this one here. And obviously it's given the different categories, different colours. Still not a huge size, and you can see the distributions they're kind of they're quite spread out. There's not too much bunching, but one thing that is interesting, you seem to have at this end, you seem to have these kind of bimodal peaks. So certainly for third and second, and this is obviously there were more younger people, more children, I guess, in third and second class than in first. These were obviously older and wealthier people in first class on the Titanic. Okay, so that plot there, you can see how I've specified the arguments. I've said x-axis, Titan data frame, and the categorical class variable, y-axis, Titan data frame, and age. Could have done exactly the same thing, but slightly different. I could have just passed a string for the variable name, and separately specified it was the Titan data set to use. So it's exactly the same as the above, essentially. There is a way to it, if you want to change the order of these, so they're in ascending or descending or something like that in terms of the values, there is a way to do that. To find out how that is, there's lots of different arguments and things you can use when you're using kind of seaborn, and check out the online documentation to find out all the different kind of styling you can do. There's so much, and I'm just going to demonstrate a little bit of it at the moment. So we can build on this. It'd be interesting to sort of split these groups by whether people were dead or alive. So all I'm doing then is, to do that, I can specify color, split them based on color, or hue is the actual argument that's used. And if we do that, what we can see there is we can see the different ages of people who were dead or alive, and based on passenger class. So it looks like if you look at the orange relates to alive for the different classes, blue relates to dead. Certainly for third and second class, kind of the majority of younger people, like this would be likely see this kind of distribution, because like children were more likely to have survived, I guess, or get places on lifeboats that were available. Okay, so thing to note is, in terms of the information you get from a box plot, it gives you the median, it gives you the top and bottom of the box, the interquartile range, and it gives you the whiskers. This is all available on these plots. So if we look here, the white dot there represents the median for each of these groups. The thickest bit of line there is essentially the interquartile range, the 25th to 50th to 75th percentile of the data, and these thinner lines represent what would be the whiskers of the plots. Okay, but then, like I say, we've got this additional bit of information that the shape of this, the KDE, the kernel density estimate it gives us, tells us kind of a little bit more about how the data was distributed. Okay, so I'm going to add another argument here. I'm going to say split equals true. Let me run that. And what this has essentially given us is, rather than splitting each group into two violin plots, it's basically split a single violin plot, so it's no longer symmetrical. Okay, so hopefully you can see that. So we've now got one violin plot for each passenger class, and the blue is still representing dead, and the orange is representing alive. So each side of the violin plot is now presenting different data. So we're able to actually see the distribution of dead or alive by group just on a single violin plot. Size scale, you can obviously see that it's given us similar information to this one above, or the same sort of information, but it's kind of a little bit neater in that sense. Okay, and these will be the same size. They will kind of integrate to one as third kernel. They're kind of a probability density function. But if we could change the scale of them by adding this scale equals count, because at the moment it looks like these relate to the same amount of information, but they don't. We can't tell whether there were. We can see the kind of ages, difference in ages on people who died or were alive, but we can't tell whether more people died than survived in each of these groups. But if we specify this scale equals count argument, then we see a much more interesting picture, essentially. So the size now of the kernel density is split across the whole of the data for each group. So what we can see here is, essentially, when we're looking at the difference between dead and alive, you can see in third class, much fewer, much smaller number of people. The counts of those who survived, who were alive, is way smaller than those that died. But if we compare that to first class or even second, the numbers who died is much smaller than the numbers that are still alive that survived. Okay, so it's quite interesting that we can get much more information out of a violin plot with these different parameters we can specify using seaborn. So there's one additional one I'm going to add, and that's scale hue equals false. Run that. There we go. And what you then can see is we've gone, so if I kind of just trying to fit them both on the screen at the same time, but hard to see really from these the difference in counts, I suppose, essentially, between first class, third class, second class. But I guess we would assume that there'd be few people first class, a few more second class, and kind of the majority of people third class. And that is kind of what this is telling us essentially. We've got scale hue. Yeah, we've set that argument equal to false. You can see that now, the difference. So I guess for the overall data, we're seeing that kind of more people in third class than in first and second, and you can see kind of the largest proportion of people who died were third class passengers, didn't get a space in a lifeboat. Okay, so that is violin plots. Lots of useful information we can obtain from them. Matplotlib, as ever, is great, for creating these types of plots. Seaborn makes it easy for us to obtain them, essentially. So nice to use Seaborn, and there's lots and lots of different style elements and arguments and parameters you can use to specify different things using Seaborn. I've just demonstrated a few here. It's kind of worth looking at the online documentation to see what other stuff you can use, essentially. Okay.